Hey there, Blue Squadron fans. In this video, we are going to reassemble the Super Star Destroyer. I'm going to start by installing a micro USB charging port and a power switch underneath where the bridge is. I'm using a Dremel to cut out a slot for the USB charging breakout. It's going to be wide enough and thick enough for the PCB to fit through, but not the actual micro USB connector. I'll solder in the lead wires to the underside later. Next, I'm going to use a drill to cut out a hole for the body of a panel mount switch. I'm using the sides of the drill bit much in the same way that a router is used to cut into the edge of wood. In fact, if you've ever seen a CNC router work before, that's the way it cuts out pieces of wood. Once the switch fits in the hole, then I'll drill in some tiny holes for really tiny screws. Now for the wires. I'm using some yellow and orange wires to connect the switch, because the colors don't matter since they're just going to be a bridge connection, and then blue and gray wires for the charging port. The colors for the charging port do matter quite a bit. Blue is going to represent ground, and then gray is going to be the 5-volt lead from the USB port. If you plug it in backwards, you could really fry something there. After soldering the wires to the switch, I'm going to test it out on the PowerBoost 1000C. If I connect the switch to the enable and ground pin on the PowerBoost 1000C, it allows the switch to close and bridge the connection between those two pins, effectively turning off the power output for the PowerBoost 1000C. This turns it into an on and off switch. It'll still allow the USB charger to work, but there will be no power output to the LEDs. Now to solder the USB charging header. I'm putting the header in place and then soldering everything to the underside. By soldering in some extra header pins, it actually clips the plastic of the city block in between the header pins and the micro USB port on the other side. This is going to hold the USB breakout board in place. To attach the panel mount switch, all I have to do is hold it in place with some bolts and teeny tiny hex nuts. While I didn't need to, I went ahead and cut off the rest of the excess bolts. I just didn't know whether or not they were going to interfere with anything inside of the main engine compartment. Main engine block is the space where I'm going to connect all of these headers that I just soldered into place on the switch and the micro USB charging port. In doing a test fit of the LED controller and the power module inside of that engine compartment, I found that it was a little too shallow to use straight header pins. Since I was only using 6 of the 12 channels on the LED controller, I went ahead and used my flush cut trimmers to cut off the right angle headers for those LED outputs. After using a solder pump to clear out the header holes, I went ahead and soldered on a right angle header for the inputs for the LED driver. Some planning ahead at the beginning of the project would have saved me some time, and I could have just used right angle headers to begin with. I did some more plastic removal in the interior to give myself some more space to run those wiring harnesses. With that done, it was time to test out the LED controller. I plugged everything in, including the ATtiny85, into the LED driver and turned it on to see the engines glow. Since I was using the software from the Lando's Millennium Falcon, there was a holdover bug with an LED for the engine that instead of pulsing seemed to cycle all the way up to its maximum brightness, then drop back down to 0. I don't have it on video, but it turned out to be that I was using a 16-bit integer for the LED brightness when I should have been using an unsigned 16-bit integer. It's the kind of thing that really only makes sense to electrical engineers and computer scientists. Satisfied that everything works and I have the correct channels plugged in, especially for the LEDs that are driving the fiber optics, I use Gorilla Tape to secure all of the wires in place. You don't want anything coming loose when you're trying to reassemble the Star Destroyer. There's not enough space to stick a breadboard inside of the Star Destroyer, so I'm going to go ahead and use that last wiring harness to create a 5-volt rail and a ground rail. This is going to provide power distribution for all of the different components, specifically the ATtiny85 and the LED driver. I tried doing a simple test where I tried plugging in the 12-channel LED controller into my power rails to see if I could get a status light to come on, but I got a weird result. Status light didn't come on, and the power module started heating up dangerously, and I got a weird error signal coming out of it. It turns out that I got some of the wires backwards. If at all possible, you want to use consistent colors for wires throughout your entire project. Amazon sells only red and black wires, then I would buy very many of them. Now to solder jumper wires onto the ATtiny85 controller. This is kind of the point of no return for this chip. You had to have flashed it with the firmware, and you won't be able to flash it again afterwards. If you mess up though, it's okay. It turns out these chips are really cheap. You can buy like 5 of them for $1. Now for the moment of truth. Plug everything in, turn it on, and try to countrify the entire model back together. If you do everything right, the model should securely close with just the plastic clips and not the screws. This is an important check to do to make sure that you don't have any extra wires hanging out in places where they shouldn't, where they could be possibly damaged later on. If you're good to go with that step, then you can go ahead and add the screws back in and mount the top half of the hull to the bottom half of the hull. Compared to other models, this screw system is pretty nice. If I was reassembling an X-Wing Miniatures model, because of all the electronics, I'd probably have to super glue the shell back together and clamp it to hold it in place. However, at this point I kind of ran into my first nightmare, which is, well, when trying to put the model back together, everything fits until you turn it upside down, and all of a sudden nothing fits together ever again. It turns out that my wiring harnesses that were inside of the main engine block could only be placed in the engine block from the top side, not from the bottom side when trying to reassemble the model, so I had to remove quite a bit of plastic to get them to fit again. I had to be careful not to cut any of the wires that I'd already put into that little clown car of a space, but other than that, it was pretty easy to do. All the areas where I was cutting are being covered up by that large engine block cover. After that, I attached the smaller engine nozzles that serve as covers for those additional screws. You'll notice me futzing around with this particular engine cover, and it's because I had the wrong side. It's probably best if you label each of those engine covers after you remove them. With all of the engines in place, it was time to take those original screw covers that I had so much trouble removing and pop them back in. And now you can get to the satisfying portion of the reassembly where you remove all of the excess fiber optics to expose the fiber optic lights. However, this was followed by the not so rewarding tasks of having to patch and fill all of the holes and gaps where light was leaking through, and then doing an emergency splice on an LED where the ground wire had failed inside of one of the engine nozzles. I have about 14 hours of this process on video, and the whole thing took me about 20 hours. Was it worth it? Well, I hope the results speak for themselves. I'd like to give a big shout out to Paul Conrad for asking me to do this model for him. He took a big leap of faith in trusting me because success really isn't guaranteed for this type of process. There's a lot of trial and error and a lot of things I had to do twice. It felt like a lot of the time, the results could have gone either way. In the end, this is one of the better pieces of work that I've done. If you like what you see here, please subscribe to my channel and check out the other videos where I do LED mods for X-Wing miniatures. If you want to try this on your own and you have any questions, feel free to leave comments and I'll try to answer them. As always, thanks for watching.